Today, we're going to explore the Physics Bible to discover the latest enhancements, features, and facts as introduced in the newest release, providing a comprehensive overview of the updates and improvements made, which are meant to transform our searchability and bring stability into our lives. We believe that the hunt for the gospel truth of civilization has always ushered in a new era. Welcome. Today, we are talking about the human eye, the camera, and the slide projector. Today, our triune component for discussion
The human eye is an optical instrument in nature. It is very sensitive. The vertical section through the eye is shown as seen in the diagram.
Accommodation. This is the ability of the eye to adjust the focal length of its lens so as to form clear images of objects at different distances on its retina. Accommodation. Then we have binocular vision. Binocular vision is the overlapping of two images of different perspectives formed by both eyes, which are combined by the brain for a perspective to be interpreted. Persistence of vision. This is the retention of the sensation of vision for sometimes even after the light is removed, even after the light source has been taken away. Near point and far point. The nearest point at which an object can clearly be seen is called the near point. When you pick up an exercise book or just pick up your phone, place it in front of your face, then begin to move it forward, bring it closer to your eyes. The point at which you can see clearly on your screen is called the near point. And for a normal eye, it is around 25 centimeters from the eye. It is also known as the least distance of distinct vision. On the other hand, the farthest point at which an object can be clearly seen is called the far point. For a normal eye, there is no limit. The far point is at infinity. Yes, you can see the diagrams as displayed. You can see the near point, 25 centimeter. You can see the far point. You can see the rays of light from infinity or at infinity entering into the human eyes. The eye defects, the defects of vision, defects of the eyes. When eyes are not functioning normally, they are said to have defect of vision. The main types of the defects of the eyes are long sight, which is hypermyopia. Then we have short sight, which is myopia. So his near point from the diagram, O, is farther away from the normal near point. We have the normal near point to be 25 centimeter. So the person with long sight cannot see clearly at 25 centimeter. So rays from an object at normal point is brought to focus behind the retina. As such, he cannot see the object at end clearly. So that gives us long-sightedness. If the ray from a far object at O, they will be focused on the retina and he can see the object at O clearly. Long sight can be corrected using a suitable convex or converging lens placed in front of the eye. You can see your diagram there. You can correct long-sightedness by using a converging lens. O is his near point, then N is his normal near point or the standard near point. The converging lens reduces the divergence of the rays entering the eye from an object such that they appear to be coming from his near point O. The clear image of the object at N is thus formed on the retina. Presbyopia is a condition of long sight caused by weak ciliary muscles due to age. It is caused by the eyeballs being too long or the lens is too convergent. His far point is nearer than the normal far point, so it's below 25 centimeters. You can see that from the diagram as displayed. Rays from the distant object are focused in front of the retina, and such he cannot see the distant object clearly. If the rays were to come from a nearer object at F, they will be focused on the retina and he can see such objects clearly. Short sight can be corrected by placing a suitable concave or diverging lens in front of the eye. F is his far point, infinity is normal far point. Remember, the diverging lens diverges the rays from a distant object and makes them appear to be coming from the person's far point. Now the simple camera. The simple camera operates on a simple principle or similar principle as the human eye. It consists of a light-proof box with a converging lens in front and a light-sensitive film at the back. So we can say it is a very simple device that uses a single convex lens to form a real inverted image on a film. The film is coated with a light-sensitive material such as the emulsion of silver bromide on a transparent or paper base. The lens focuses the image on the object to be photographed on the film. The distance between the lens and the film is equal to the focal length of the lens. The diaphragm regulates the size of the aperture, which controls the amount of light energy sensitizing the film. The shutter, which is of variable speed, controls the exposure time, the time interval during which light is allowed to fall on the film. The film is wound on the spool. Some cameras have bellows or focusing rings with which the distance between the lens and the film can be adjusted. This ensures that images are sharply focused on the screen. A better image could be obtained by replacing the converging lens with a system of lenses. The lens is pointed at the object and light rays from the object enters the camera and are focused on the film, forming an image on the film. For a camera that has focusing rings or bellows, the distance between the lens and the film is adjusted using these devices until a sharp image is seen on the film. The light causes chemical changes on the surface of the film, and the film is thereafter treated with chemicals in a process called development. Light is finally used to make a print of the image from the film on a special paper. So without light, there is no sight, there is no photograph. What are the similarities between the human eye and the camera? The human eye is impregnated with black pigments within itself. The camera is a light, tight box painted black inside. So they both have black pigments within themselves. Number 2, the pupil in the eye serves the same purpose as the aperture of the camera, the pupil and the aperture. Number 3, both have converging lenses. The retina of the eye functions like the film of the camera. The iris of the eye serves the same function as the diaphragm of the camera. So we can see these as the similarities between the eye and the camera. What are the differences between the human eye and a simple camera? The human eye has power of accommodation. It alters focal length of lenses. But for camera, it has no power of accommodation. The focal length of lenses are constant. Number 2, distance between lens and retina is fixed for the eye. But for the camera, the distance between lens and the film can be varied. For the third triune component is a slide projector. We can call it projector. We've seen a projector being used in our schools, in church, and in different media for presentation. The projector is an instrument for projecting an enlarged image of a transparent object which is slide on a screen. Preferably, this screen can be a white screen. Now, when you look at the projector, we have a concave mirror as a part of it. We have the light source. We have the condenser. We have the slide carrier. We have the slide itself. We have the projection lenses. We have the image, and then we have the screen. The light source is a powerful source that illuminates the object, which is the slide. It illuminates the object called the slide. So if you look at the similarity between the human eye, the camera, and the slide projector, you realize that light is constant. Without light, in physics, when it comes to practical, in optics, we need light. Without light, in fact, in all the practicals in physics, without light, practicals cannot be held. And that is it. So, without light, there is no sight. Remember that. The concave mirror helps to direct the light onto the condenser. Then what happens? The condenser, which consists of two plano-convex lenses, collects the light and concentrate it on the slide to illuminate every part of it. And this happens evenly and strongly. There is usually an infrared filter between the two lenses to prevent the passage of heat to the slide. The slide carrier is a framework on which the slide is placed inverted so that it can appear upright on the screen. A projection, which is the projection lenses, produces a real, number 1, enlarged, number 2, inverted, number 3, image of the slide and focuses it on the screen. So the screen, usually white, receives the image. The principle of the projector is applied in, number 1, cinema projectors. Then we have photographic enlargers. Connect to our social media handles at Physics Bible the Triune Physics for latest update. Thanks for joining us. Stay equipped, stay liquid.